So when you look at this respiratory quotients, or called RQ value, so the definition of RQ value basically means that the volume of carbon dioxide produced divided by the volume of oxygen used in a respiration. So basically, it depends on how much oxygen we consume, and how much CO2 produced in one respiration. Okay, so what's so important about the RQ value? So the value of RQ show two things: type of respiration, whether aerobic or anaerobic respiration, and also tell us respiratory substrate use. Are you clear? If the RQ value less than or equal to 1. Okay, RQ value less than or equal to 1. Okay, if you calculate the RQ value less than or equal to 1, this is aerobic respiration. Are you clear? If you calculate RQ value less than 1, so this is aerobic respiration. So if the RQ value less than 1, then from this RQ value, we will be able to actually predict what is the respiratory substrate. So let's say, for example, if RQ value equal to 1, then the respiratory substrate is carbohydrate. Okay, but if the RQ value more than 1, so this is anaerobic respiration. So why? Okay, why aerobic respiration RQ value maximum equal to 1? So you look at the equation here. When we say aerobic respiration, means that we must have sufficient O2. So means that O2 volume must be high. So if you look at the equation, if the O2 volume is high, RQ will be low. So means that RQ value will be less than or equal to 1. 1 basically means that we have the same amounts of volumes of O2 as compared to the CO2 produced. But if let's say in the anaerobic conditions, basically we have insufficient O2 cannot. If insufficient O2, so basically means that O2 concentrations of volume is low, so RQ value will be high. So therefore, RQ value when more than 1 is anaerobic respiration. Okay. So if you look at this, what is RQ value? So RQ value for carbohydrates equal to 1, lipid is equal to 0.7, protein equal to 0.9. Okay. So, but sometimes question may give you some value in between. For example, if you have any value, the RQ in between 0.7 to 0.9, then we can say that it's a mixture of lipid and protein. Are you clear? Okay, but if the RQ value very near to 0.9, let's say 0.85, 0.89, then we can say that majority are proteins. Okay, so if the RQ value in between 0.9 to 1.0, this one is a mixture. Okay, they can use a protein together with carbohydrate. Okay, so how we calculate RQ value? Okay, so for carbohydrate, I use glucose. For carbohydrates, I use I use this glucose as our model. To see. So how to calculate RQ value now? In this case, RQ. Let me show you guys first how to answer this question because it's very common. So C6H12O6 plus balance equation 6O2, you get 6 CO2 plus 6 H2O plus ATP. Okay, but here I remove the ATP. Okay, so balance the equation in this case. So now how to calculate RQ value? If RQ, we need the volume, cannot. But we do know that in terms of the gas, number of mole. Okay, how many mole actually correlate it with the volume, correct? If under standards, okay, if not mistaken, under standard atmosphere and the temperature, okay, not room temperature, okay, then you were going to get say 22.4 dm cubes, right, per mole, right? So in this case, instead of using volume, I can use a number of mole, okay, because the number of mole corresponding to the volume. So the RQ value equal to the volumes of CO2 released over the volume of O2 produced, consumes. So therefore, volume of CO2 equal to 1, equal to 6. This one, O2 equal to 6. So RQ value equal to 1. Clear? Okay, I've done for glucose. So now take a bit of time, calculate the RQ value for oleic acids now. So same thing plus O2, we are going to get CO2 plus H2O. Okay, so how to balance the equation? We calculate total how many carbons here? 18 carbons, correct or not? So means that here must be 18. Can I see that? Correct or not? Okay, you calculate here C17 plus C, so total 18 carbon. How many hydrogen? Hydrogen, you can see that 33 plus 1. Can I see that? 33 plus 1. So total 34. Okay, 33 plus 1, so 34. Okay. Sorry, 34 divided by 2, so 17. Cannot. Okay, so I have 18 carbon, I have 34 hydrogens. Okay. So now, how about oxygen? How many molecule oxygen we have here? How many atom? Okay, we have 18 multiplied with 2, so 36 oxygens atom here plus 17. Cannot. Okay, so 3, 13, so 53. Cannot, 53, right? Total oxygens here. Okay, 2 multiplied with 18, so 36. 17 here, so 53. So 53, you have to minus out 2 here, correct not? Okay, on left hand side. So means remaining 51 because divided by 2. Correct not? Okay, so total we have 51 here. So what is the RQ value? RQ value equal to number of CO2 produced divided by the number of oxygens, okay, the number of mole on the volume of oxygens used here. So divided 51 over 2. So calculator, 18 divided by 51 over 2. So you get the answer 0.71 or 0.7, okay? Do you get this answer, guys? 0.7? Okay, good.